Alright, looks like we are live. Starting a little earlier today than normal, and I'm also doing this on a Tuesday, which is right after Monday, and I don't normally do back-to-back streams. So yesterday we made some significant progress on developing, if not coding, the material system for Enterprise. Let me go ahead and just relaunch the editor. And we uncovered during development some things that seemed to be a little bit of a hurdle. Primarily how to handle texture arrays and 3D textures. Hey Yoshi, welcome. It's nice to see somebody popping in right at the start. How are you doing? Anyway, I've been mulling over this problem, and I think I've decided that I'm going to go ahead and do texture assets. I'm going to do a quick survey of the ways that texture assets are imported in engines, and talk about what I chose and why. So I think a lot of indie folks are really interested in, or they're really familiar with how Unity works because they use Unity the most. Unity, when you drop a file into the content browser, it will make an invisible meta file. It's .meta for each file that you insert. And that's one way to do it. However, I think I've developed a slightly different approach that'll work a little bit better. Doing good. Got a big W in Apex. Nice. I was never very good at Apex. By the time, by the time I had joined, I think for me, like the reason why it was hard for me to get into Apex was that like it didn't have like a single player component, and like in a lot of first person shooters, I would like depend on the first person shooter campaign to like teach me how everything worked. And like with Apex, there wasn't any of that, so it was like you're learning it on the fly. And by the time I started playing, which was not very long after it came out, everybody was already way better at it than me, and so it was like discouraging to keep working at getting better, and so I just didn't. But nice. Anyway, so there's a couple of different approaches. Unity is still booting up. It's like importing default assets or something. And in Unreal, we've got sample project loaded up. I think this is the I have a couple of simple projects going. This is the built-in template for top-down, like Diablo style. Got 9 kills versus 1300, or sorry, 9 kills, 1300 damage. Nice, man. That's pretty dope. That's far better than I ever got. Nice. I don't know what those guns are, but I take it that they're good ones. Anyway, so we mentioned briefly in Unity, whenever you go to import an asset, the asset will appear inside of the content browser, but inside of the folder view, inside of the Explorer, you will see a .meta file associated with it. Unreal works a little differently. Unreal takes and encapsulates the data inside of the asset, plus all of its metadata into something called a uasset file. And so actually it doesn't even matter what kind of asset it is. It comes out as a uasset file. So the advantage of these systems is that it kind of simplifies the user experience a little bit, where you drag and drop an asset into your game, or into your game project, and you just see it, and then you work with it directly, and you're not thinking about metadata. You're just taking and editing the metadata on the file. However, that's not a perfect process either way. For one thing, you can't use a raw asset file in more than one processed asset. So if you were to want to, for example, in Unreal Engine, you can't directly take and make a texture that has multiple map settings at once, or multiple import settings. You can't take a sprite sheet and then like use it in the game as both a sprite sheet and a regular texture. Maybe that's an arbitrary restriction, but like it's something to consider. Is that in the general case, the idea of taking an asset that might contain multiple things, and then not being able to use that same asset in multiple use cases in the engine, that's kind of a limitation. Because if I wanted to take a model that contained like a Blender file that contained multiple models, and I wanted to use them for separate meshes, I would have to like break it up first, and then I wouldn't be able to like edit the one blend file and then have it update all of the other assets. So it's there's a couple of ways that you could probably imagine some scenarios where that's restrictive and you wouldn't want it. In Unity, the thing I don't like is that it's got all those downsides, but it's also hiding data from you in some sense, and that makes it a little bit obtuse. So let me open up a texture location inside of this Unity project. For every single texture we have in here, we have a .meta file, and the .meta file, we open it up in VS Code. It's just a YAML file, basically referencing the the raw asset by name, and then putting in all the metadata that you set inside of the inspector. So basically all the import settings go here. And the more I've been thinking about how I want to handle importing, the more I realize that there's no getting around this problem. You have to, like, you can't, like, if you were to come up with a way like Unity's, where you're hiding the metadata, so you don't actually see, you're not like consciously thinking about where the metadata is on disk. You're kind of once removing yourself from the way things work. And so I've decided that instead of going either approach, where we either bundle up the asset and the metadata in the same file, or we put a invisible metadata file for all assets, all raw assets, I've decided to just completely separate the concerns. When you bring in a raw asset, like in Enterprise, let's say we have these textures, the images themselves, I don't think that they are going to be used directly in the engine anyway. So I've decided to do a kind of asset file paradigm where every time you want to use something in the engine, you create an enterprise asset from it first. So, for example, you would make an EP text file for a texture that you want to use in the game, and this would contain the reference to the raw file, the raw image, as well as all the metadata associated with it and all of the import settings. And I kind of thought long and hard about whether or not this was desirable. It's a little looking at just blank icons like this. You could think of it as like maybe it's a little hard to follow with your brain. It's a little hard to parse visually, but eventually it's not going to look like this. It's going to have a preview for the textures, previews for materials and things like that, so you can take a look here and then not really be confused. There's visual indicators we can use to make it easy to tell apart which is the enterprise asset and which is the PNG file. And then also, if you utilize an asset, a raw asset, in multiple places, that can automatically update anything that references it. So if we were making a pixel art game, for example, we have sprite sheets for character animations. We could, if we wanted to, separate those out into multiple files and then have a single. So we have like multiple sprite sheets, one for like each area or article of clothing or whatever, and just have it like have a workflow where you're producing a sprite sheet for a category of animations or something like that. Then you can make a texture asset that takes all of these sprite sheets, splits them all up, and puts them all in the same texture array, so that they're all available and easy to use inside of the same sampler, inside of your shaders, something like that. So I'm going to start by eliminating the original texture import API. Set up a YAML-based texture file, which contains all of the metadata that we care about when it comes to, or contains all the import information we care about when it comes to setting up in the engine. And then that will be the base for handling packaging when we finally get to the point where we're packaging up assets for use in a shipping game, where it's not raw PNG files being shipped and it's not text files that we're loading. That's a long ways off. Probably not even going to do that before we make our first game with this. But it's laying the groundwork for something important later. So yeah, that's the goal today. Once we have this done, where we have the texture files referencing PNGs and whatever, then we will have a solid bedrock upon which to finish the material system. Because one of the problems that we had with the material system was that how do you reference multiple textures inside of a material, especially when some of those might be texture arrays and they might use multiple PNG files. With texture files, it's way simpler. You just have for every sampler, you assign it a EP text file, and that's it. So yeah, that's where we're gonna start. Now, I've been thinking a bit about the current situation with YAML. So far, I've been using probably the most popular C++ YAML library, YAML CPP. And YAML CPP has been good to me getting started with YAML, but I'm starting to get really frustrated with it. The first problem, which is something that I've just been kind of glossing over, is the fact that it uses exceptions for catching conversion errors and things like that. And then the second is that every time I want to use a std string container, like if I want to get the text out of a node, like as a value, it has to construct a string, then copy it into my string. And it does that every time you go to take text out of the file, and it's like these are things that feel like they're obviously going to be slow, like it's like I'm not at the point where I'm doing like optimization checks, but we're starting to have a lot of code for simple things. Let me take and uncomment out the code we did yesterday. I had to comment it out because it wasn't quite finished, and I wanted to be able to build and run Enterprise without it. But like taking a look at this code, it's like you put a try block, and then at the very bottom of the try block, you do the catching of the conversion errors or whatever, and then when you go to do your checks, you're beyond all these if statements and whatever. You're doing .asString and whatever, and each one of these does a construction of a string, and then an assignment conversion or whatever. It's like there's a whole bunch of these little inefficiencies that are growing, that are making it a little frustrating to work with this library. So today, I think I'm going to try a different library out. There's one that I saw called Rapid YAML, and it appears to take care of almost all my concerns. For starters, it's not constructing a whole bunch of things all the time. Like the one of the goals of this library was that it was supposed to be useful in embedded situations, which have to be like really fast in most cases. And so there's some tests, and specifically it's like a million times faster than YAML CPP, but it's also faster than a lot of other libraries that were checked for parsing. But also the API seems really simple. It does have a tree-based API, which is what I like. Basically, you load up the YAML string. So in this case, they have this is the two lines where they create a buffer, and then they create a tree from it. They use parse in place. You pass in the buffer. It doesn't copy the buffer. It just takes the pointer and constructs the tree from it. And then you have a tree structure from which you can do key lookup like this, or you can do index-based lookup and iteration. And it gives you all the means you need to avoid having to do like lengthy searching through things. It's internally modeled as a linked list, which allows traversal to be pretty fast if you're keeping track of which node you're in. So yeah, I think I'm gonna start by adding this library, and then we'll use it for the implementation of texture files. If I like it, then I'll keep it and get rid of YAML CPP. If I don't like it, then I can still use the algorithm we develop in YAML CPP. It'll just be slower. So let's start with that. Let me do a copy. When I was adding my other Git submodules, for the longest time I was using SSH, and I forgot that not everybody has that set up. So this is a heads up: if you're making your own libraries, you should always use the HTTPS when you are adding a Git submodule, because if you clone a repo that has submodules and its submodule uses the SSH path, that user the person who clones the library has to also have SSH set up, and if they don't, then they can't clone recursively. Anyway, so for this I will use terminal. Not that terminal though. I'll use git bash. Okay. Git status. Probably have some. Yeah, these are all the things that the temporary files we're working with. So we're gonna need to do git sub module. I think it's git sub module add. I always have to Google this. It's such a simple thing, but like I always have to Google it. I'll say git sub module add remote and then the destination folder. So add and then the remote in this case is the link that we just copied. This is one where I really doubt that I'll be needing to do changes to it. If we take a look at the pull requests, there's only 3 open pull requests. There's a handful of issues that are open, but like whenever like 121 close, whatever, like whenever somebody pushes a fix, like the author seems to be either closing or pulling them. So it's reasonably up to date. So I'm just gonna do a clone of it directly instead of my own, instead of a fork. And then we will add this to enterprise. Oh, sorry, engine slash. That'd be engine vendor, and then I think that's all I have to do because it'll. Let me double check. Vendors, cloning into home main project. Yeah, I think that what it'll do is it'll make a folder named after. Yeah, so that's good. Get some module add. Yep, run it. Fatal engine vendor already exists in the index. Oh, maybe not. Maybe I have to name it after the project itself. Where's my Git modules? Yeah, let's give it. Let's give it its own folder. That seems wrong. Let me double check. What I don't want is to have a module that's like have it be like a subfolder that's an unnecessary interaction. I'm sure that you just do /vendor and then that's it. Okay, so I have to use /, I guess. Let's try that. wasn't it? All right, let's try this one. Rapid YAML. Okay, and let's confirm. We go to engine, vendor, Rapid YAML. Okay, yeah, so Rapid YAML, so I have to actually specify the name of the folder that will house the repo. Okay, that's a little different than when you go to clone. When you go to clone and you don't specify a path, it will actually automatically make a folder name, but that's okay. Cool, so now we got a module for it. I know that this is CMake powered. Let's see if we can get some insight to confirm that we can just add it. Okay. Yep. This is a pretty simple looking file. Sources. C4 add library. That's interesting. C4 require subproject. C4 core incorporate subdirectory. Oh, okay. This uses itself. It uses submodules. Okay, so I need to init submodules. I think it's like get submodule init. I forget. Gets a module in it and then gets a module update. Okay. Cool. Let's do that. So here we will. That's interesting. CD engine vendor rapid YAML gets that status. Confirm we're seeing it. Good. And then we will do get submodule init. Okay, and then we've added the C4 core extern. Get submodule update. And it should clone it. Cool. This is why submodules are so great. All the dependencies will just automatically come in. Enterprise's own CMake file automatically runs recursive or runs the cloning of the submodules, so we don't have to worry about making sure everybody else has these dependencies. All right, back to the CMake lists for Rapid YAML. Okay, so it includes compat.cmake, which is here. OldGC C4.8. Okay, yeah. And then extern core. Okay. So I guess this is probably like a helper library to. I'm gonna look that up. A helper library to make CMake projects easier. How to build. Oh, this is YAML CPP. Let's go to Rapid CPP. Or Rapid YAML. Here we go. Using YAML in your projects, single header file as a library. But if you wish to make good use of CMake and its tooling ecosystem, you have the option to integrate RYAML into your project setup. Yep. CMake is required to build. Yep, that's fine. Okay. Get clone recursive. Yep. We didn't use recursive, but we used submodule init and update. Oh, it says update init recursive to ensure. That's interesting. Maybe it might be the case that the submodule itself has its own submodules. Okay, it does. Yeah. So now we've got. So yeah. So C4 apparently has its own submodules that we needed to have it check out. So I'm glad I read the instructions. Quick start samples. Yeah, whatever. Sample name, single header. Okay, so there's multiple CMake lists that show it. Sample name, single header lib, add subdirectory, fresh content, find package. I use add subdirectory typically. This is a pretty robust implementation. So if I click the link, it'll show me how they typically use it. This is great. This is how a library should be documented. They should like make using it the easy part. Or make setting it up the easy part. So you make minimum required, yeah, project. So they use add subdirectory on the RYAML folder. And then they just do target link libraries with RYAML. And then what's going on down here? Add custom target. Run. YAML quick start command. Runs the YAML quick start. Okay, that's unrelated, I think. But cool, yeah. So I guess it's really as simple as that. So let's do it. So I'm gonna close everything, including the materials file. Make it a little bit easier to follow what's happening. And then we will go to CMake lists for the engine, and we need to add the submodule. Okay, so this is the section where we do CMake subprojects. Right beneath YAML CPP, I'll add this guy. Again, if we like it, we will keep it and get rid of the other. I always like to use the library's correct capitalization, so in this case it's Rapid YAML like that. Whereas these literally all stylize themselves as lowercase. Rapid YAML. And then we'll say, I guess we'll do the same thing as we did up here. We need to do a check to make sure that the submodule was cloned. Or do we? YAML CPP was in this project, I think, before any of the others. So now that I have the enterprise CMake lists automatically do recursive cloning, I'm wondering if this is important, whether I even care about it. Because we don't even bother with the check on the others. Yeah, okay. So I'm actually going to do away with this check. That's not really important anymore because we don't require developers to use recursive. We just have the CMake lists automatically ensure that the submodules are automatically added up. This is where we actually do all the setting up of the subdirectory. In order to make YAML work, and this is another thing I don't like about it, I had to make modifications to the CMake file to even make it work as a library without complaints. And actually, I think there still is one complaint. It tries to use it checks the presence of a package that it doesn't actually use, and so there's always a warning saying that it couldn't find that package, and yeah, whatever. But anyway, Rapid YAML. We'll do add subdirectory, and we will do the path is relative to the engine folder. So we'll say vendor slash r YAML, or Rapid YAML, yeah. And then I guess we don't have to add the alias. With free type, I added an alias for free type. This is to make sure that when I link to it, it's not trying to link to anything else. It's not trying to link to a folder. It's trying to link to the library. I'm not exactly clear on the reasons why that's best practice in CMake, but it is apparently. However, inside of CMake lists for Rapid YAML, I'm willing to bet that they already do that. Well, I'm not seeing it inside this file, so maybe it's part of C4 project, but I could have sworn I saw it in here. Yeah, that's right. So when they go to target link libraries to link the library, they use ryaml : ryaml, so it's got an alias set up properly. That's great. That's way easier to set up. Cool. So here we just add the subdirectory, and then we need to add the target, add the link to the target. So build flags, ID, project organization. This probably needs to be updated. There's a section down here that's specifically meant to make sure that if you make a Xcode or a Visual Studio project, that it will be organized logically, but I haven't bothered with it for a while. Headers. Where's the link dependency linking? Okay, here we go. Target link libraries for the dynamic version of the library and the static version. So right below what we have YAML CPP, we'll do ryaml. Cool. And then one of the beautiful things about CMake is that it should automatically bring in any dependencies necessary. So that is by merit of saying I want to use this library, it will automatically ensure that I have the correct header paths, so I can actually just start using it in my code. All right, the configuration's done. RYAML says using C++ standard 11. That's interesting. I wonder if I can change that to 17. Setting C++ standard required on. Importing subproject using C++ 11. Okay, so that seems to be configuring correctly. I'm sure if I build now, it'll compile just fine. Let me take a look at those instructions again, because there's probably a list of settings I can use as a library. Okay, good. Those are the quick start examples. CMake build settings for YAML. Okay, the following CMake variables can be used to control the build behavior of RYAML. RYAML with tab tokens. Enable, disable support for tabs as valid. Container tokens after : and defaults to off because this may cost up to 10% processing time. Okay, so we are using spaces for everything in Enterprise. I guess this means that because we provide interfaces through which somebody can do their own YAML extensions to Enterprise files. I guess this means that we're going to enforce spaces for YAML files. I'm not sure if I really care about that, but for now I'll leave it like this until it becomes a problem. Default callbacks, enable, disable the default implementation of error and allocation callbacks. Okay, what's the default implementation then? Is it like std out or something? I'll worry about that later. Standalone on-off. RYAML uses C4 core, low-level multi-platform utilities. when it's on, it's incorporated. Default's on. Yeah, I'll just leave that on and see when to turn it off. If you're developing YAML or just debugging problems, then these can be helpful. You can do development and debug. That's fine. I don't care about it right now. Probably not going to use that at all. YAML is strongly coupled to C4 core, and this is reinforced by the fact that it's a submodule. It's possible to use a different version. Okay, whatever. Good. Now I wonder if there's a note in here about C++ 11 or 17. Okay, so there's not any notes in here about changing the language standard through which it compiles. So that tells me that that node is probably just a procedural thing. I think I'm going to see if I can't find that in the CMake file somewhere. I'd like to know whether there's some logic in there that changes it from C++ 11 to something else. Okay, here we go. C4 log using C++ standard. Okay, so even though it says YAML here, this logic came from the C4 library, CMake, so I guess that's just a automatic thing that doesn't tell me that we can use C++ 17 or something like that. Good, so everything seems to be working good. Everything compiled like immediately correctly. That's great as well. 0 warnings too. Isn't that something? I can't even say 0 warnings for YAML, and I spent a while eliminating its compiling warnings. So I'm liking this already. Good and good. So now that we've got it, we should be able to just use it. So let's go to textures.h, and we're going to change up a few things. For starters, I'm going to eliminate these loading calls. Load texture array. And you know what, I'm also going to eliminate the regular load texture call. We're going to replace all of this with a single call. So inside of the graphics API, we will now use load texture, but instead of doing all of these parameters, we will just take a std string path, and that's it. That's the whole thing. That's the whole enchilada. And the reason why we're doing it this way is because now with the advent of texture files, or texture asset files, the texture asset file will contain everything we need out of this. Or you know what, there is one more thing that we need. We need to have size t instances. Because we're still reference counting the texture. The difference is that the path will be to the asset file instead of to the PNG file, or the bitmap or whatever. So cool. And then let's implement this in textures.cpp. I hit Alt-O, but it didn't. Okay, there we go. So inside of here, we're not going to simply comment this code out, but we will comment out these, all these load textures. They were all unimplemented anyway. In this one, the logic is actually pretty complicated for loading up a texture. So what we're going to do is we're going to replace this signature, and then just update this function to match the one that we have in here. Okay. Good, so we make sure that we have at least one instance, because if you're calling this with 0 instances, you know, hang on a minute. It might be better, instead of asserting here that you have at least one instance, it might be better to just have it return early if it's 0. Because I could imagine some strange scenario where somebody wants to procedurally load instances of a texture, and then they don't want to have to do an if-else check on whether it's whether the instances that they pass in is 0. So let's change that. Instead of doing an assertion that we have instances, we'll say if instances equals 0, equals 0, then we will say return 0. That'll just be a no error condition. In fact, not even a situation where we would issue a warning, because I'm just going to make it legal to pass in 0. Okay, then we have the texture out. So this is where we have to start doing the YAML stuff. So we're going to need to do, we're going to need to load the YAML file. We're going to need to parse out the parameters that we just deleted from the load texture section. And then we need to pass them into this logic. So I guess I'll make a helper function for this real quick. It'll be a static. We'll have it return. No, you know what? It would be easier just to do it in here. So let's get the parameters that we want to use. We want to have texture filters for min and mag filter, and we want to have the bitmap mode. So these are things that we'll parse from the YAML file now. So let me make this a little bit better. Okay. Min filter, mag filter, bitmap mode. So these will be parsed from the file. So we'll start with a comment to make sure that the logic is easy to follow as we make changes to this already very large function. We'll say parse deets from YAML file. Let's take a look at that YAML file. I started working on a model of what an AP texture file would contain. So the idea is that we specify the type, the kind of texture it is. So that means 1D, 2D, 3D, cube, 1D array, 2D array, or cube array. These are the only texture types we support. And then we specify a sequence of paths, so basically just an array of paths like this. And then we specify whether we go to slice it. So columns, rows, and count. If you're just doing a regular old texture, then these can be all one. But if you pass in a single texture and then you slice it up, that'll be the equivalent of producing a sprite sheet. Basically, you take a sprite sheet, you say divide it up this way, and there's 20 frames or however many frames you want, and then this will be used to produce an array. So this actually is optional. That's something that you would only pass in with the 3D. Oh no, that's not true, because if you have a single image, then you could take a 2D image and split it up into 1D textures and stuff. So yeah, so this will be provided, and then we'll just use it slightly differently depending on the type. And then if we have paths, then it'll be the same thing. It'll be equivalent to adding additional PNGs or adding additional image files will be equivalent to adding more slices. So it'll add elements to an array. It'll add layers to a 3D texture. And then we have min, mag, and mip. I'm going to start by doing a very simple a very simple implementation that doesn't even consider array types. We will skip types. We will skip slices. We will make path just a single string. And then we will have min, mag, and min-map mode. Because right now we only have support for that kind of texture, a 2D texture or a 1D texture from the PNG in question. So this way we can focus on the parsing and then worry about updating the logic later, because up until now I haven't even bothered to implement cube maps and 3D textures and things like that. Though it is good to plan ahead, and so we have a structure that we know will be useful going forward. Cool, so this will be a very simple file to parse. If we go back to this guy, head to, or sorry, that's the H file, save that though. There we go. So here we'll need to do some YAML parsing, and this is where we take a look at the tutorial on the new library we're using. So basically they get a buffer with the string in it, so we'll need to do the same. That means that we're going to use the enterprise file API. So file, load text file. We pass it a path to a file using the virtual file system, and we pass it a reference to a string that will receive it. That should probably be a pointer. I think it's a little more explicit to have a pointer when you're doing an output, but whatever. So we'll need to have an std string that contains the YAML. I'll just say YAML source. And then we will pass in the path. So path is provided as a parameter to the load function. And then we will pass in YAML source as the destination. This returns an error code thing, so we'll say if that returns true. If that equals file error code success, then we'll move on. Else we've got a problem. And we'll say, hey Goku, welcome in. We're trying a new YAML library while working on this problem. But welcome in. How are you doing? Here we will do ap error. We'll say graphics load texture unable to open texture file. I'm doing all right. I'm doing pretty good. I'm firing on all cylinders. I'm at that point where I've spent a lot of time planning ahead on a problem, and then I'm just really eager to implement it. I stayed up pretty late, not because I was working on the problem, but because I was thinking about actually implementing it. There we go. So this is the very basics. We load the text file, and then we have the source file. This needs to wrap the whole rest of this. 2 days in a row you're in beast mode. Yeah, I usually will prefer to work offline for a while in between streams, but I'm at a point where I'm actually just ready to code, and I don't have to think so hard about the design. All right, so I need to wrap basically all of this logic with the if-else block. I will do that here. Alt-Shift-F to do plain format. So we have an if-else now, so if it's able to open the file, we do all this logic. Otherwise, we return 0 and we issue an error. Cool. You guys weren't here at the very beginning, but I'm thinking about changing to Rapid YAML instead of using YAML CPP, because I'm starting to get really annoyed by all the try and catch blocks that I have to write for it, and there's obvious APIs that are doing things that seem to make it too slow, like constructing strings just to get the buffer out. Rapid YAML seems to be the answer to my prayers, so we spent the first little while adding it to this project as a submodule, and we're going to try it out for this logic, and if we like it, then we'll just replace YAML CPP with it. But for now, cool. So we've got the file loaded, and in here we need to actually create the tree. So I'm going back to the tutorial. Here it is. And that's done by making a RYAML tree and using parse in place, passing in the character buffer. So RYAML. Oh, I have to. There's one more thing I have to do. That's in VS Code. I'm not using the configuration provider from CMake tools anymore because it's slow and it's error prone. Then that means that I have to go into CPP properties .json, and I have to actually go and pass in my includes. So let's add another for Rapid YAML. And what is... I'll have to actually look up its includes. Option, sources. This actually might not be as straightforward as I would like to identify, because it kind of looks like they use C4 to handle the process of... Oh, here we go. Add library, sources, include directories, excuse me, build interface, which I think is, let me double check what build interface does. Content of ... when the property is exported using export, or when the target is used in another target big in a single system. Okay, so the includer is this variable. Where do I get it? Are you thinking of making money out of this project? Making money in the sense that I hope it'll be a good portfolio item and somebody will hire me. But no, this is an open source project, and I don't think that anyone will want to spend money on my first game engine, or my first production game engine. So no, this is free. It's going to remain free. If I get to a point where I want to try and sell a game engine for money, I'll probably be starting from scratch using the lessons I learned from this engine. But yeah, I may ship some games out of this engine though, and try and sell those. That's something I might do. But no, this is mostly for portfolio working. Yeah, it's really interesting. Where is this? Oh, I didn't actually copy the correct thing out. that's why. Okay. Your next step should be 3D. Well, that's a little bit of a misdirect, because you're doing 3D and 2D at the same time. There's no getting around 3D in graphics programming, because all the graphics APIs will they'll have a normalized coordinate space that's 3D, and you're doing 3D math, even if the thing that you're doing is ultimately a two-dimensional game. Because you see when I go flying around in the engine in the enterprise editor, it's 3D space, even though I've only got 2D sprites. Yeah, the frustrating part about the way that I'm approaching this, and like I still believe in my approach, but like the frustrating part of the approach is that I'm developing the framework through which I make all the cool things, not the cool things themselves. So I'm not working on renderers right now. I'm not going to be working on renderers for a while. I'm not working on a whole bunch of stuff. But once we're done with it, it should be more straightforward to do things like 3D renderers or 2D renderers or whatever. But the framework is the thing I care the most about. Okay, yeah, I'm sort of confused. I'm searching for all instances of this variable, REML sourcedir, and I don't even see where it's set. Maybe there's something special about C4 add library. I tell you what, I'm not gonna keep digging and finding the location for the include directory. I'm just instead going to change my configuration provider and let CMake Tools find it for me. So let's do that. Configuration, change configuration provider, make it CMake Tools. And hopefully that'll be enough for IntelliSense to locate everything I need. But yeah, anyway, REML, I believe was the name of the thing. REML tree is what we're looking for. Oh, I need to also include the header, which is what REML.hpp, I'm assuming. That's interesting. So it doesn't even have an include slash. IntelliSense seems to have located the path. Oh, it doesn't. Oh, okay. So this library is apparently laid out very great, except for this one thing that it's a little nitpick. I like to be able to do library slash and then whatever for my includes, and it appears that I have the entire source folder, Rapid YAML / source. The entire thing is inside my include path, and that's gonna pollute that namespace a little bit. But you know, whatever. Yeah. So we do. REML.hpp apparently, and if we go back to where we were writing code here, wait, was it here? Where's the code I was working on? Oh, here, it's down here. Good. So it'd be REML tree, okay, and this will be, I'll just call it tree, and we'll set it equal to REML parse in place. Okay, parse in green, I'm not sure what that does. Parse in place, and we pass in the buffer, so we can do a C4 substring. I'm not really sure what C4 substrings are. I'll have to learn about the C4 library. What they did in the example was they just passed in a regular character buffer. So I guess it would be YAML source dot cstring would be one way to do this. And that'll bring in everything from that file, I assume. No instance of overloaded function matches the argument list. Oh, okay, it needs to be non-const. Okay, that's something. Does it just take regular STD strings? No, I guess not. What if I included REML dot or RYAML std.hpp. That kind of looked like it was for this purpose. Yeah, it uses std string. Okay. Head back down. RYAML parse. Your face trying all the things, that would have made a good meme. Yeah, I'll have to go rewind and see what my face did. So I guess C4 substring is of note. Do they make mention of std string? It's emitting, deserializing. What did you have for breakfast today? I went to the diners. Yeah, I just oatmeal and coffee. Nothing crazy. Okay. So it doesn't look like they've got an example where they're creating a tree from a std string. Is there more robust documentation on this? Let me pull up parse in place real quick. Okay. Had a good pancake with cinnamon on it inside of eggs. That's tasty. There's a place near me that it's like next to a nice restaurant or nice diner where they do brunch and stuff. Right next to it, like owned by the same people, is a waffle cart, and it's always there year round, but it closes the first week of November. And I've been here a year and a half and I haven't tried it. I'm gonna have to try it soon. These freestanding functions use a temporary parser object, convenience to easily parse YAML without the need to instantiate a separate parser. Okay, fine. What are these other parsing methods? Here in Las Vegas, we have everything from all over the world. Yeah, that's pretty dope. I'd imagine that the dining is pretty good. Never been to Vegas. Of course, everybody tours Vegas for the gambling mostly. I mean, there's cuisine, but you know, like they go because that's where the casinos are, right? Okay, so there's a parser class that's used. Use an existing parser. It also yeah, parse YAML code in place, potentially mutating the buffer. It is also possible to parse a read-only buffer using parse in Arena, reuse an existing tree, reuse an existing parser. Okay, so what I think I'm going to do is I'm going to actually step away from std strings because it doesn't look like they have direct support for this. You have to make a mutable buffer and then pass that in, and so I can't just do std string. Wait, can I do std data or YAML source data? That might be the way to do it. Is it inline char? Okay, yeah. So actually, data is not mutable. Inline. Gambling is tempting. Had to control myself. Don't do it. You'll lose all your money. Yeah. Yeah. Gambling is a slippery slope. Okay, so I can pass in .data. That gives me a car pointer to the data. But that's not enough for this to work. So yeah, what I'll do is I'll go to file.cpp inside of here. Actually, I think this is maybe an implementation specific thing. I'm not sure, but I'm looking for file. Load text file. Okay, so load text file. This is the function that we've been using. And basically we take a path to the text file and then we pass in a reference to the out string and then it populates that string. I'm going to do a version of this that is very similar except for it'll populate a C character buffer. Even slot machines, I saw people for $200 then lost it all. Ooh, yeah. You can't parse to what they ask. Put $200. Can't parse to what they ask. I'm not sure what you're asking, Yolan. But here we go. I'm basically just going to do an implementation of this that's a little bit different. It'll need to return a buffer. So what I think I'll do is on the one hand, I could pass in a character buffer and then populate that, but I would need to know in advance that the size was enough. So what I might do instead, I might just have an allocation of the buffer in here once I know the file size. Because we do have logic for finding the size of the file. And then I will just take in. Oh, I don't like this at all. The method asks for a specific type of string. Is there no string.parse on C#? It's a no-brainer. Yeah. So the complication seems to come from the fact that this library uses a sub-library called C4, and so it's not actually using C or C++ string types. It's using, let me head back to the file. When we use parse in place, it takes C substring types, which is not an actual C++ or C type. It's a C4 type. Or it takes, where's the other? Well, it's literally all just the C substring type. So it is apparently a template. My impression is that C4 is intended to be a boost style library where it has a whole bunch of low-level things, and it's used extensively in this library. And that's actually making it a little bit harder to get started with it. I was looking at the README of this and I was thinking, oh, this code looks really straightforward. Look, they just have a character buffer and then they pass it in and then that's it. But maybe not. That's how one lady lost $1,000 off a digital poker. Jeez, that's crazy. It's so sad, so sad for me. But mostly the movie theaters here are in casinos. Oh, geez, yeah. Yolan, you're not too dumb for C++. C++ is a dumb language. It's not your fault that it's hard to understand. So, let me take a look at some of these quick starts. There's probably something in here that I'm overlooking. Okay. Let me look at all the places where they do a YAML tree. Oh, okay, here we go. So they have std string contents. They have a file apparently that gets you the contents of a YAML file, and then they use this ryaml parse arena ryaml to c substring. So I'm not really clear on what parse arena does, so I'm gonna have to look that up. But apparently, ryaml to substring is enough to get a substring type out of a regular std string. You know what's funny? I see slot machines in gas stations. Jeez, that's crazy. It's like, because it can't be cheap to set up a slot machine somewhere, right? I'd imagine that it would cost the gas station owner quite a lot of money, but okay. It seems like this is the way we're supposed to do it. I don't understand what parse arena does. That's probably a term that is computer sciencey. Arena versus in place. Today it's 92 degrees. Oh geez. Yeah, that's pretty hot. What is it where I'm at? Let me check. Yeah, it's a cool 64 degrees where I'm at in Washington. Yeah, 92 degrees is crazy. Okay, we're learning things. Region-based memory management. In computer science, region-based memory management is a type of memory management where each allocated object is assigned to a region called a zone, or blah, 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 all these things. Is a collection of allocated objects that can be efficiently reallocated or deallocated all at once. Like stack allocation, regions facilitate allocation and deallocation of memory flow overhead. Okay, so apparently this is a way for them to avoid having to allocate directly on the heap. So I can use that with high performance expectations. Yeah, thankfully we have houses and things to keep us from the elements. But yeah, otherwise I would be cold. Yeah, so we'll use the parse arena business. It was ryaml tree equals ryaml person place. Okay, so this is what we'll use. ryaml parse arena ryaml to c substring. That's a little awkward, but I guess it's my fault for using std strings everywhere. All right, so this will be like this. Parse arena to c substring, and then we wrap the std string with it. Okay, that took too long to come across. So now we've got a tree node from the data we ran and from the source file. And then we need to start using it. So let's go back to the quick start, which was here. Good game. GG. That was down here. All right, so we're going to be using the tree API. So basically, we just do these checks. We check to see we check the return value of a search for a key. So we do tree and then the key in quotes. the way that this API, or the way that this quick start documentation works is that they basically just like show you things that are true statements inside of a check macro. And then you can identify how to use things. Trees map ready already. Okay. So we need to check probably root is map because we want to make sure that we have a that the file that we opened it has a root node that's a map. You're looking you're cooler? Yes, I feel pretty good about the temperatures in Washington State. So a little bit. It's rarely bad. We don't get it too cold. We don't get it too hot. We get it just right for the most part. But anyway, so we just want to do trees map. And then, do I actually need to pass in the root ID? There's map and size t node. So the gist is that each node has an ID that's universal throughout the tree, and then each node's children can be accessed with an index, which is different from the ID. About 68 degrees in Canada. That's crazy. That's exactly the same temperature as it is here. Though I'd probably prefer to be in Canada. Wait, 68 degrees Celsius. These Celsius in Canada, right? So that's 68 degrees is that's twice as hot as 100. That's like 200 degrees Fahrenheit, isn't it? So that's Fahrenheit. Okay. I don't have to think in Celsius very often. It's about 20 Celsius, yeah. Okay, so for some reason you have to do tree.isMap isSequence and pass in the ID instead of just checking to see whether the tree is a map. Oh, because it's a tree and not a node reference. Okay, I think I'm following. So if you get a node out of the tree, then you can just say isMap, isSequence, or whatever. Otherwise, you have to do get the ID. So and then pass in the ID for whatever it is. So let's get the root node. Let's do auto root node equals tree dot get root reference. Okay. So this gets the root as a node reference. So that'll be YAML node ref, like that. And then we can do things like root node dot is isMap, right? Okay, cool. Okay, so this is making quite a lot of sense to me. So we'll say we'll do all of our checks. Root node is map, and we also need to find the other children. So for that, we would say tree.find. Let me look for that. Well, a lot of is, yeah. With and this is kind of the thing that sucks the most about writing parsers, or even just using libraries to parse, is that you have to do a whole bunch of conditional checks. So the simpler the format of the thing that you're working with, the fewer checks you have to do. So I'll get a root node. Let's get back to the texture file that we are parsing. So we're starting very simple. We got the root node, we got path, bin filter, mag filter, and min map mode. So say path node, and then min filter node. Oops. Mag filter node, and then mip map mode. Or mip map is one word. Mip map mode node. Let's call it a mip map node. And then equals tree dot find, was it? I guess it just did you have to use the square. You can just use the square braces with the quotes. The thing though I want to know is I want to confirm that this actually gets me a reference. So how do I check to see that it's a valid reference? I'm not seeing anything in here that would tell me how I can handle the absence of an expected key. Yeah, the slowest part of this is just me getting used to this new library, which I went through this when learning YAML CPP as well, so I guess it's to be expected, but I'm slowly getting it. Alright, so let's do a tree, and then we'll pass in the key, and then I guess we'll have to find some way to confirm that they are correct. Let's say min filter. I forgot to do path node. And I'll bother putting in the correct keys in a minute. Min filter node dot valid. Okay, so you have a validity check inside of the node. Let me double check. Returns mtree is not equal to null pointer and mid is not equal to none. Okay, so this will pass me a reference. The reference can still be bad, and then I can do valid to get a bool to tell me whether or not the key actually exists. That's actually really nice. That actually makes the code really straightforward to read. So I don't... Yeah, so I get the root node, path node, all these nodes. So when I'm looking for a specific node, or node subnode, I can just do the search, and then I can do, if it's valid, then do the thing to it. So we have root node.isMap, and then we can do path node dot valid and path node. Oops. Path node dot is key val, meaning a key value pair, and then do this for the rest of them. Okay, this is starting to make a lot of sense. So let's get the proper key names in here. So this is going to be path. This is going to be min filter, mag filter, and map mode, like that. And then I'll do is valid and is key val for the rest. And the rest being root node. Wait, not root node. Min filter, mag filter, min map mode. Cool. All right. Good. And we're doing really simple right now. We're just getting the bare minimum, the path, the min filter, mag filter, min map mode. So these are all just key value pairs. In the future, I will be doing paths instead of path, and that will be a sequence of strings. And we'll do slices, which is going to be another key value pair situation, another map. Cool. So, and that cleans up really nicely too with the plain format. So yeah, I'm starting to really like this library. Okay, so if root node dot is map, path node dot valid, path node key val, min filter is key val. Okay, yeah, this is all looking good. So we'll do all of the logic in here. Else we do EP error, and we'll say that we're missing data. Well, actually, we don't want to be doing an error condition on all of these things at once, because there's some things we can survive without. We can survive without these. We can't survive without a path. So what we'll do then is we'll do the must-have stuff first. So we'll say path node dot valid, path node dot. I wonder if these have is valid checks in them. Because if there's a validity check baked into is key val, then I don't see why I would need to use is valid. Hang on a minute. Tree is key val ID. Is it that hard to locate this? Unknown and unnamed types. Okay. Let me find its implementation. Here. What here? M type is key val. Okay, return type and key val equals key val. And type if I go back to the validity check, validity check doesn't relate to this. What is your streaming schedule, dailies? I have been doing Monday, Wednesday, Friday. I think I'm at the point where I'm pretty much settled into like around 10 Pacific on Monday, Wednesday, Friday. That's a pretty decent schedule. I've been ad hocing it a little bit. Today I wasn't planning on streaming, but I did. So I'll probably be putting that in the schedule for Monday, Wednesday, Friday, 10 a.m. But subject to my whims, which kind of sucks. But what I really want to know is if I don't have to do a validity check, because I don't like the idea of having to do dot valid and then dot is key value pair. There's got to be looking at you devouring codes and libraries gives me hope for my future. Glad to hear that. It's I think it's the curse of programming that you can't fit it all in your head. So even if you're doing something that you have done a lot and you know how it works, you're oftentimes just Googling how to do it just because you forget the exact things that you're supposed to type. That's not the case here. I'm just learning how to use this new library. Yeah, the thing that's not clear to me is whether or not I can use isKeyVal in a case on a node that's not valid. Let me search for this in the quick start. It kind of looks like they're skipping the isValid check. So demonstrate in-place parsing of mutable YAML source buffer. They do a check that the root node, they get the tree, the node ref for the tree root, which is actually what I did. That makes sense. They check that it's a map, and then they plug in keys, and then they say is key val, and if it is, then they do a thing to it. So it's not explicitly stated here, but I'm interpreting from the way that they use the code that the validity check is unnecessary, because the check to confirm that it is a particular type would be false if the reference isn't valid. So it's a little bit of a risk, but I'm going to go ahead and use the code that way, and then if that causes a problem, and I'll have to do some tests to confirm that that's a problem, then we will go back to doing the isValid stuff. All right, cool. So we've got all the nodes that we care about. We just need to do checks on them. We'll say if root node dot is map. If it's not a map, or let's say if it is a map and path node dot is key val, then we're off to a good start. Otherwise, we have an invalid file we can't recover, so we would do an EP error on that. And then the next check would be to see whether the path is valid, I suppose. So we would get the path value, path node. So that'd be path node dot value dot val. This will get me a C4 substring. There we go. And that'll get me a string back, I guess. So the question is, how do I go from that into an STD string? Can I do that? I guess not. Do we have more YAML helpers to STD string or to? So we have 2 substring and we have 2 C substring. Because of a C++ limitation, substring cannot provide simultaneous overloads for constructing from a car end and a car star. The latter will be always chosen by the compiler. Okay. So what do we got? We got 2 chars, 2 tag. Well, legitimate documentation. Yeah, that's great. It's great to have that stuff pop up. And actually, given the style that they used, I'm actually surprised that it's working correctly. There's probably documentation for all of those members, but it's just not popping up because of the way that it's typed. For my own API, I'm taking great care to make sure that the functions will tooltip correctly in VS Code, Xcode, and Visual Studio, as well as have HTML documentation. But there's some developers that really hate having to do that. So yeah, so this is how I get the value. The thing that's really annoying me is that I don't really understand the C4 substring type. And I guess I'm going to have to do that in order to understand how I'm supposed to work with these. Okay, a non-owning string view consisting of a character pointer and length. So this is looking into the arena allocated buffer that we have the characters in. That's my understanding of this. So yeah, I guess that makes sense. I think I'm starting to understand how this will look in my code. So I don't need to store the text path. I don't even need to do that in a stack variable because I can just directly pass the string view into my API. So what I will do is I'll do file exists and then pass in the path, so that'd be path node.val, and then I need to find a way to convert that into an STD string, or I need to support string views, which I probably should do anyway. Let me make a version of that supports STD string view, and I'll see whether or not that converts. Wait, STD string view is C++ 17, isn't it? Yeah, C++ 17, and this is compiled in C++ 11. So it's not going to have an implicit conversion to it. Rats. So I will have to construct from a C4 string view into either an STD string or an STD string view. My preference would be the latter. String views are great because they give you the wrapper handles that are comfortable with regular STD strings, but they don't allocate new memory. They just point to a buffer that you have allocated somewhere else. So far, none of this code that we're working on is reallocated the buffer that I initially loaded from the file, with the one exception that it is arena allocated for the sake of operation in Rapid YAML. I think I followed that correctly. So there's probably something on this. C4 string view to STD string view. I'm imagining that C4 is fairly popular. Some of the utilities already have equivalent functionality, but they're provided as the existing equivalent may be insufficient, inefficient, or heavy. That's interesting. This is compiled in C++ 11, but they make reference to... Oh, wait a minute. Let me do a reconfiguration. Plate cache and reconfigure, and take a look at this CMake output. Okay, so our YAML is using C++ standard 11. So I think C4 core is using C++ 11 just because our YAML is. So if we had, let me take a look at Rapid YAML slash, what's the location for all this C4 core stuff? Rapid YAML slash external slash C4 core. Right? Vendor Rapid YAML ext C4 core. Okay. And then we'll search for STDs, mentions of STD string inside of or string view inside of. Okay, so there's only one reference in C4 core to STD string view. So that library itself does not provide any conversions to an STD string view. It probably provides a conversion to a string. So I'll need to provide the conversion myself. So what goes inside of, let's pick apart the string view type then. Heading back to textures.cpp, we'll go to val, and we'll take a look at the C substring type. So the basic substring, and it has a pointer. C is probably a character type. Non-owning string view consisting of a character pointer and a length. Okay, so it's got a string and it's got a length. Let me pick apart that C type. It's class C. What I'm thinking is that I can construct a string view using members of that return val. So let's head back to textures and let's see what I can get out of it. Dot. So there's. So if I do .str, I get a pointer to the first character of the substring. How about len? Length of the substring. Okay. So I can construct an std string view here and then use it. Well, is that class C code's unreadable for me? It is. Well, it is sort of. It's a template. I don't know if you're familiar with templates. It's a little complicated, but generics in C#, because I think I remember you were saying that you were a C# person. Generics in C# are a way for you to use any type in a function or something like that. It's a substitute for a type that's determined at runtime. Templates are like that, but they're determined at compile time. So you can use a templated class, not a generic, or a templated function, and the compiler, when you go to use it, it will then add a section to your code that handles that type. It's a tricky, cool thing, but it can make compilation times take a long time sometimes, and it's sometimes complicated and sometimes makes your code borderline unreadable. But yeah, that's what's going on here. It's a template class C, so the C class is actually literally anything that is a class that gets passed in here. So it's intentionally vague. It looks like here C substring and substring, they pass in for that class. Well, class is maybe a misnomer here then. I think because it says class, but these are actually just types. The type that they're using for C is const char or char, and so inside of basic substring, when we see C star, we're looking at a character type, whether it's constant or non-constant characters. So inside, whenever I go to get the C4 string reference, or C4 substring is what the type was, then I can do .str, and that will get me the first character of the string, and then I can get the length as well. And those two things are all you need to construct a string view, because you can say, hey, here's where the data starts, here's how long it goes, use that in your string comparison operations. So yeah, I can actually take advantage of that. It does mean, though, that I need to make a quick change to file .cpp. So I want to use the exists check. This is a simple check where you say, hey, here's a path. Does this file actually exist? That's all we care about. And then I want to use that as a check. I need a version of this that accepts an std string view. And an std string view basically just gives you a it's basically the same thing as a string, except for it doesn't contain its own memory. So what I could do for this, I'm going to actually cut the implementation out of the top version of this function, paste it into the string view version of this function. And virtual path to native path now. I guess I'm going to have to real quick go through all my file functions and make sure that they all support string view, which I probably should have done to begin with, but whatever. So string view path, it does this whole thing. When you pass in a actual string reference, then you can, what we can do is we can just invoke this version of it, from the data inside of this reference. Cool. So that would be exists and then we would call it with a string view constructor, which I believe just takes path.data and path.length. I'll double check that. What's the error now? More than one instance of... Okay, so... Oh, this can actually construct both a string view or a string, so I have to be explicit. I like this. Yeah, thank you. Will cascading change happen to the best? Yeah, good to know. It's a thing. I'm at the... Like, the whole reason why we're going through this exercise is because, like, I'm evaluating this library to replace another library, and that'll be another cascading change. Because, I mean... It's all well and good to save yourself time by not fixing things, but you don't want to be, waiting so long to do the change that it becomes impossible to do in a practical amount of time. Yeah, so getting away from YAML CPP, I think it's been bugging me for a while. If we can get away with it with this library, that'd be great. But this is still a test. I haven't actually removed or extracted YAML CPP. We're just trying it out for this feature. Anyway, I can't just do initialization using curly braces because that could either be an std string or an std string view, making the overload ambiguous. So we actually have to do std string view here, and we'll pass in the two parameters, which it's the const car pointer and the count. So that's it. So now the implementation's up here. So we support both string view and string, except for we have to do the same thing to virtual path to native now. So this will be we'll use the same style of implementation as we did before. We'll have the version that takes a path that invokes the version that takes a string view. And we'll do std string view, passing in path.data, path.size, like that. And then I have to change this to use an std string view. Wait, that's not right. String view, not string view. Cool. All right. And then the logic actually works out pretty much the same down here. Oh, but then we have to return an std string. Hang on a minute. I'm thinking my way through this. We actually, on virtual path to native, we actually do depend on having a mutable buffer. So I'm thinking about that. Oh no, this one, okay, I got confused. This one doesn't require a mutable buffer. I was thinking of native path to virtual, and that requires a mutable buffer because we're actually constructing a string there. Here, what we just do is we take the contents dir path and then we concatenate the substring from path. Now the problem here is that this is not actually an std string itself, so the types don't match. What we need to do is we actually need to construct a string from this. And then concatenate that way. I suppose we could also use like printf or something, but whatever. This is something that we're not going to call very often, so I'm just going to go ahead and construct a std string here, and then hopefully the compiler will be smart enough to optimize away and make this a little more straightforward. Cool. So path.substring. So we're lopping off the first couple of characters. And we're concatenating that to the path, the virtual path, or the path to the virtual drive. Good. And then same thing down here. Good. And And because the whole point is that we're constructing a path to pass out, we actually do need to do another conversion down here. This is what happens if the drive is not actually present inside of the path that we pass in. So we pass in a virtual path. Virtual paths start with C, D, or S / for the content, data, and saveders directly. There's also the editor content and editor data, so that's conditionally compiled here. If none of those are present, then we just return the native path, but we still have to construct it because we are doing a mutable array out. Already done. That was a peanut challenge. I think I anticipate more problems that I'm not seeing with this code. I'll eventually have to come back in and redo the file system, so that way I do this for all of the file system functions. But this should be good enough for now. Hopefully. I think there might be a compiler error that I'll have to worry about at a later time. So now that that's all done, if we come back to here, we say file exists, path node.val. This gives us a this gives us the C4 string type. What we can do here is we can say std string and convert or string view. Convert it. Oh, but there's no direct conversion. So what we do is we do dot str. Is that a function or is that just a member? I think that's just a member. Okay, path node dot val dot len. Yeah, that's another member. Okay, and then that gives us a const char. That gives us a size t length. What's here? No. Oh, hang on. Did I get exists? It accepts a string view now. So what am I missing? No user defined conversion from std string view to const std string exists. But I'm using, I have two versions of this now. Oh, I didn't put this in the header. That's why. Whoops. That's probably what I was thinking of. All right, so engine include enterprise file. Yeah, so I actually had to do the overloads in here now. So we did virtual path to native, got another one, and then we got exists, got another one. Okay, so we'll mimic the style of the implementation where we do string view above and string below. And the documentation is actually exactly the same, even though they're different types. The purpose of path is unchanged. So I'll just copy that. And I duplicate the documentation for the sake of Doxygen. So when I go to generate my HTML documentation, it actually displays both correctly. And also so that when you mouse over, it gives you a better experience. Cool. Convert, yeah, path, yeah, equivalent. Yeah, okay. Okay, so save that. Head back to textures, and suddenly we have code that works. So that's good. Where are we? Here. Okay, it's still a little bit wordy, and this worries me because like for now, I'm doing internal code. I'm using the YAML library to do my texture files. However, at the foundation of enterprise is extensibility, and I need developers to be able to utilize a YAML library or utilize a YAML library to insert their own YAML into proprietary enterprise file. So previously what I was doing is I was passing in a YAML CPP node, and then they would use the YAML CPP library to inject data into like scene files, for example. If I replace YAML CPP with Rapid YAML, I would need the ability to pass in YAML node references from our YAML into my own API for developers to use. Or I would need to come up with my own API, and I don't really want to do that. So if they use Rapid YAML, if I make Rapid YAML the thing that you use in enterprise, then I would potentially be exposing developers to all of this. If they want to use file exists, they have to do a string view construction from their node or something like that. That's not great. So thinking this through, for ways to make this a more elegant user experience, something I might do is I might add support for, instead of using std string and std string view, I might add support for literally the C4 string types, just so that it's easier for developers to work with both my API and work with the Rapid YAML API. Alternatively, I could come up with a wrapper for our YAML and make an API that doesn't re-implement everything, but it wraps it in such a way that it's easy to use and works well with my API. I don't know, I'll have to think about that, but for now we'll just continue with the logic we were doing before. So first thing we're doing is we're checking to see that the file is valid, and that means that the root node of the file is a map, and that the path node exists and is a key value pair. If the file itself doesn't exist, then we've got a problem. So we do if exists, we pass in the path that we got from the path node. If it doesn't exist, then we'll say else error text file doesn't exist, and then I'll come in and actually do error response as soon as I've got this if-else structure figured out. And then at this point we know we have the texture file, we can use it, or at the very least we can plug it into a texture load function. So now what we need to do is we need to get the min filter, mag filter, and bitmap mode. And for these guys, we will provide a default value if the file is missing these properties. Because texture files, I'm imagining, will be set in the editor using the UI, I don't expect there's going to be situations where these will be missing. So this is going to be an example of where you would use a warning instead of an error, because you want to say, hey developer, there's something up with your texture files, but we can recover from it otherwise. So what we'll say is we'll give these a default. So texture filter, min filter will be, I'll do linear for each of these. And then for bitmap mode, the defaults I'll say is none. Wait, bitmap mode, none. So we don't generate bitmaps, we don't linear interpolate between them. We do linear interpolation between the texels inside of the texture, though, for minification and magnification, because that's more common than anything else. I wonder if it would be better to say nearest by default, because it'll make it pop out a little bit more. Yeah, I'll use nearest. Okay. Nearest point sampling is where you get the pixelated look from, where it's not trying to smooth out the texture in between pixels or texels. Okay, so we have the defaults, and then we'll say, well, I'll need a helper function. Do I have those? I need a way to convert these words into these types. So yeah, so let me add those functions up above. In renderer 2D, I had a thing. I had some helper functions in here that did this for me. During parsing, and they would come in real handy right about now. Found it. Okay, so these are the functions. String to MIP mode. MIP mode should be MIPMAP mode. And then string to text filter. And there's also the inverse of that down below for when you go to serialize. I'm going to hold off on that. I'm just worried about loading right now, not saving. So we'll copy these helper functions out. And now that we're changing to using texture files, I don't need those helper functions inside of the renderer. You're not going to use them at all. You're just going to load the texture file, and that means that this code is the only code that has to care about parsing min filter, mag filter, MIPMAP mode from the file. Cool. So we need to do some changes. So this is MIPMAP mode, and nearest nonlinear. Good. And then this is going to be replaced with graphics load texture. Like that. Bam. Like that. And we don't have anisotropic filtering yet. We will, so I leave these little comments around because at that time I will add the logic. But yeah, nearest linear for text filters, none nearest linear for MIPMAP modes, proper error messages, good. All right. These take std string references though. And in this file, we're only going to be working with those string view types. So let's do, instead of an std string or an std string view, let's do the C4 type, which again was, I think it was just like string or substring, I think is what it was called. I'm trying to find the val function so I can control click on it. There we go. Yeah, so val gives you a C substring, which is, okay, so the C stands for const, I think. Okay, so we would use C substring from this header. Presumably that's visible in this layer. So back up to our helper function. Instead of doing this, we will do that. Error type, EP graphics C substring. Maybe I have to use it in an namespace. Oh, it's in C4. So C4, : C substring. Right? This declaration has no storage class or expected a parentheses. What are you complaining about? This declaration has no storage class or type specifier. So yeah, I don't think I really get it, because this is supposed to be a alias for this template. Is there something unusual about the export? That doesn't look like it. Huh. Yeah, screw it. I don't want to spend more time on this. I'll have it take a std string view and std const reference, because I'm not going to change it. And then the logic inside will be the same. But when I go to use it, I will have to construct a string view. And I'm okay with that. Cool. All right. So, oh, you know what? These functions already do the default handling. These will return nearest or none with a warning if they don't convert. So down where we were working, I don't have to do this. I just have to do str to text filter, and then we will do the string view construction. So it'll be this is unambiguous, so we can use the braces this time, and we will use min filter node dot val dot stir, and then min filter node dot val dot len for length. This constructs a string view which calls this, and then we get a warning if the value is incorrect. Cool. So I think that's making sense. So we'll do the same thing for these guys, using mag filter node and mag filter node val and length, or stir and length. And then here we will use stir to map mode. And then for it, we pass in the map node, oops, instead of the min and mag filter node. All right. And that seems to be good enough. I'm Alt-Shift-Fing to do a little bit of formatting. And then the only other thing I can think of that we want to check is that before we do each of these conversions, we need to actually confirm that these keys themselves are valid. So we'll say if min filter node dot keyval is keyval, yeah, is keyval, then we will do this logic. Else, oops, else we got a problem. And that problem is warn warn node is invalid. And I guess, yeah, actually I do need to forward declare these, or not forward declare, I need to declare these up above the if blocks. So that'll look like this. And I will actually default initialize these two values, and that way the warning can be reduced to a no-op in shipping games. Except for we won't be doing this in shipping games because we'll have pre-processed the textures, but whatever. Texture filter nearest. Okay. And then we can do min filter equals down here. All right, we're getting there. We're making progress. Default initialization, and then each of these we will do the if else. Yeah, okay. Okay, I think this is looking pretty good. All right, so at this point, we have all the data parsed that we need. We have the path, we know that it's a file that exists, and we know the min, mag, and map mode, defaulting to nearest and none on those last three. If the YAML file, if the YAML file is missing these values, or if it's corrupted or something along those lines. So I guess at this point we just do the low texture logic, which means that all of these else's that we had. Let me get rid of this real quick. I don't need it. All of these else's here, Control X, belong at the bottom of this block. This whole function, basically. Down here. A little awkward, but you know, I don't like that very much. Let me undo that. The thing I don't like about that very much is that it puts everything in many levels, so it's indented quite a ways. Let's reverse these if statements, and we'll do these as early outs instead, so that way it returns up above if we have a bad situation. Otherwise, we just continue, and that'll make it so that there's not as many indents before the logic that we care about. So we'll say so success equals 0. Let me think about this. I'll keep the load texture file if block as it is. We put all these nodes up here. We'll say if the root node is not a map, or the path node is not a valid key val, then we will do the error. Else, hang on a minute. Maybe a little tricky to reverse these blocks, but it's well worth it. So invalid file error. This will result in a return. Let's do that now. And then these can all go up a level. Okay. And then we do a file existence check. Let's say if the file doesn't exist, then we will do file does not exist, or I should say text does not exist, to image file does not exist, because I have another warning for whether the texture asset file doesn't exist, so I don't want to confuse those. Return 0. And then here we go, get rid of that. Like that. Then I can get rid of one of these curly braces, and we're up level again. Okay. Oh, does not exist. Yeah. Min filter, mag filter. Okay. And then we do the min filter and mag filter checking stuff. Say if the nodes are invalid, we issue warnings, but we continue. And then we're good to go, actually. Down from here on, we can just do the logic like we did before. And in fact, all the little red squiggles have gone away because mipmap node, mag filter, and min filter, these used to be provided as parameters. I am now providing them as scoped variables, or automatic duration variables. So at this point, all of these, sorry, not all of those, all of these, min filter, mag filter, and mipmap mode, are filling in their old habits down below in the logic where we were loading 2D textures before. So I don't have to change any of that. Alt-Shift-F. Formatting already seems to be pretty good. All right. So to review the overall logic, if the instances is 0, then we would just return without an error or a warning. If the texture file can't open for some reason, then we return 0. Otherwise, we work through here. We load the tree. Do I need to do any checks on the tree? Hang on a minute. I might have to do a check on the tree. Okay, so they don't ever use tree.valid in the examples. Okay, so I'm presuming that this will all be fine. I'll have to check a few things when I test this out. I need to confirm, or I'll say tests for a second. I'll need to test that root is not a map. I need to test that path is missing. Path is invalid. Path is not an image file. Actually, I don't care about that because that's already tested for the load texture logic. We use std image to load the texture file itself into memory. That's it, actually. Those are the only tests I need to worry about. These are the situations I want to confirm work correctly with this code. All right, and then let's do the EP errors now. texture. We'll pass out the path. So this is a little bit vague, but I'm keeping that a little bit vague because it's either that the map, that the file doesn't contain a map, or that it that the path node doesn't exist. Oh, maybe I should make that a little bit more clear. Yeah, let's make that a little bit more clear. So I'll take this second check and move it into its own if statement. Like that, and then make these a little bit more explicit. This one will say the path key is either missing or invalid. And this error messaging will change a little bit in the future, because we're going to be replacing path with paths, where we're going to do the sequence of paths instead of just the single one, but that's small fish. Okay, and then we do the image file does not exist. And this is a temporary issue, so I'm not going to stress over it too much. I'm just going to quickly type a error in there. File at is missing, or will not open, or it does not exist. Okay, good. All right, making good progress. Okay, now we should do warnings for these. These warnings are going to look very similar, so I'm just going to type them all at once. So these will be EP warn, graphics load texture, and we'll say something something node is missing or invalid. And that's actually all we have to say. So this first one is the min filter node. This is mag filter. This is MIP map mode. Cool. And these are all default initialized in case the conversion has a failure. All right, that's looking good. I think that's it. That for our very basic implementation, this will parse out these 4 things. And then the logic will work identically either way. So I'll save this file, I'll use it. Let's give it an actual correct path to use. Actually, there's so many things to do, and my brain's firing off in all kinds of directions. So I'm looking for instances where I call graphics load texture. These are going to have some problems now, I think, because everywhere that I've used load texture will now load a asset file. Ooh, okay. Here's a consequence that I hadn't thought too hard about. The load texture call was being directly used in the editor. And the purpose for that was to load the folder and file icons inside of the content browser. I think the way that I want to handle that is I want to make an implementation function that's in the internal header, so it's hidden from the game layer, and then this can bypass the YAML loading part and move on. The rest of these. Okay, so this matters here. YAML. Hang on a minute. This is where we're seeing some use of the YAML CPP library. This function is deserialize sprite component. So when we go to load the scene and we go to deserialize the sprite components, the scene file currently takes min filters, mag filters, and bitmap modes, and those aren't a thing anymore. So what I can do instead, let me make these changes. Now when we go to load the sprites from the scene file, we only care about the path to the texture, and then we call load texture on that path, and then it contains the details that used to be saved inside of the scene file. This means that we have to edit the scene file now. So we've got a couple of EP scene files, basic and second scene or something. So we're going to modify the basic one. This is the one we use for all of our editor work. I can now get rid of these things: min filter, mag filter, and mip mode. We don't care about them in the scene file anymore. We still care about UVs. UVs are still handled by the renderer, but we'll eventually be addressing those as well when we move on to the material system. I guess I technically don't need to remove these from the file, now that I'm thinking about it. I can just leave these in the file and it'll just skip over them when parsing, so yeah, let's leave it like that. Okay. But yeah, now that we've eliminated the business with passing in a bunch of parameters, we need to come up with a way to get the load texture to work correctly inside the content browser. So probably what we'll do is we'll move that logic out to a implementation function that handles every kind of texture, and then we can use that directly to load the texture inside of the editor, bypassing the need for the editor to use the YAML-based texture files. Yeah, so we'll come back to that in just a little bit. For now, I'm going to take a little bit of a break. I've been going hard for 2.5 hours, and it's lunchtime. I'll be back in like 10-15 minutes, and we will wrap up these last couple of details and confirm that the texture files are loading. See you in a bit.
Let's move side to side, let's go.
Okay. Excuse me. Back. So, where do we leave off? We left off with. That's right. We got the load textures now replaced with a version that accepts these YAML files, and it will parse the YAML file for the data it needs and loads up the texture. Right now, the data it needs is just a texture path, and then the min, mag filter, and bitmap mode. And I got to take care of a consequence of that, which is that I can't use this function anymore for loading textures into the enterprise editor. Because in the enterprise editor, we don't want it to be using texture asset files. We just want it to load up directly from the image. In fact, in the future, we'll probably want to do some kind of a resource compiling thing, so that way it's not shipping with PNG files for its icons or whatever. But I'm not really going to fuss over that for now. For now, I'll be fine with loose files. I just don't want it to be using these things. So let's head back to the load texture function. The logic that actually takes and loads the texture, this is going to need to go into its own implementation function. And it will be invocable from the editor. So let me find the stopping point. That would be this entire block, I think. This entire section of code contains all of the logic that we need inside of the helper function. I wonder if I can extract. No, I guess not. In Visual Studio, you can do and move this into its own function automatically. But I guess you can't do that with VS Code's CMake and CMake tools and C++ stuff. So okay, so I'll just cut the stuff out then, and we will do a function call here. We will say return load texture implementation. And let's define the implementation, and then we will worry about the parameters. Okay. So we need to pass in the number of instances we wish to create. So size t instances. We need the path, which is going to be an std string. And this path will be not the path to. Actually, this would be an std string view. This would be an std string view because this is being passed in not by the parameter of the load texture function, but passed in by the path that we get from the YAML file. Instances, yep. It looks like I don't have a hash function for string views, which I'll have to change. And then min filter, bitmap mode, and mag filter probably are the other ones. All right, cool. So let's do that. I'll copy the parameters from the commented out version of the function. Here we go, and paste it into here, and uncomment it. it's looking fine. Inside of here, inside of the definition, the only red squiggles I've got are for the hash name function. So let's go and fix that. Presently, the hash name function can accept a const char literal, so you can do string literals, for example, or std strings. We just need to add another overload for string views. So this will be we need to go to the header actually, and then above the std string version, we will add the std string view version, and in the definition we'll do the same thing. Oh, that's interesting. We are not using const references in this original function. I don't know how that happened, but let's fix that. Okay, and then we'll duplicate the std string version, making it an std string. Oops, I zoomed out on accident. Okay. Make it an std string view version. I did have a nice break. Well, I had an okay break. I went out to, I live with my sister, and I gifted her a bike rack for her birthday, and while I was working, she had gone out to install it, and I went out to go and check it out, and it turns out she doesn't like it. So that's not great. But other than that, yeah, a little more relaxed. A little bit better. Okay, so the string view version is literally the same code. We just do string name dot cstring, I believe, and it'll give us the. Let me double check that. That seems a little bit wrong. The IntelliSense seems to be not keeping up. Yeah, so there's no cstring function in string views. However, I can get the data, and then I can get the length. So string name dot length. This is the difference between this and this is that this actually this is considered a conversion function, and this doesn't consider itself a conversion function. Under the hood, they probably do the same thing. They probably just get the pointer to the string and then give you the size or whatever. That should be length. But wait, right? That should be length. No, that should be size. I think they're the same. But I must have used size on purpose. Maybe you have to use size to get the null termination character. That's the only other thing I can think of, but I guess it doesn't matter because the length is provided to the above function. Anyway, so data and length. This will, instead of getting the pointer to the first part of the buffer, it will give me the pointer to the place where the view starts. Good. So that's fine. That should be okay. I'm slightly worried by changing these to const references that I might have had some other effects. So we'll see whether or not this compiles. If it fails to compile, we'll just make it back to by value. Okay. But now that those are there, all the red squiggles around the hash name paths have gone away. The only thing left is to pass the data in from the low texture function. So this would be, we need to get the path. So for this, we'll do, we'll get from the path node dot val, which will give us that C4 substring type. And presumably we'll be able to construct a string view from it, but I'll hold off on that for the moment. We'll pass forward the instances call. We'll pass in min filter, mag filter, mipmap mode. Out of curiosity, I'd like your opinions on game dev. I noticed that most people who develop a game solo dev most of the time don't use an engine. My question is, do you think that the tools of game engine are improper for the task of game dev in the solo team, or do you think that there is an outside factor which makes game studios with a game engine that makes game studios use a game engine with 50 to 100 employees while someone creates Minecraft out of the blue? Yeah, I would say that it's actually not at all common for solo devs to go without a third-party engine. It's actually way more common for solo devs to use Unity or Godot's getting more popular than it is for them to make a game from scratch. Though it is true that you'll find more engines from scratch on the solo devs than you will find in the AAA developers. Well, I'm not even sure if that's true if you think about it, because like AAA developers, a lot of them have their own engines, like Call of Duty, Halo, and Destiny. Wait, I think Halo might have changed over to using Unreal Engine. I'm not sure. No, I think it's still proprietary. So like all the big AAA franchises, like a lot of them use their own technology instead of licensing. So actually, that might be a little bit of a reversal of what you're thinking. I don't know. I think that none of that has to do, like the popularity has nothing to do with whether or not it's proper or improper. The only important thing in game dev is that you actually make something, to be honest. You don't want to have to, like you're not in it for the technology, presumably. You're not in it for the sake of typing and coding and whatever. If you don't make the game, it doesn't really matter what you didn't to make it with, right? So really you should just use whatever gets you going in the morning. Whatever makes it easiest for you to get a good thing done. And I think particularly Unity, and to a lesser extent Unreal, these engines have been making it really straightforward and easy for developers to start making cool things from scratch. Things of their own, I should say, not from scratch because they're using a proprietary engine. It's good to get started with something, and while it really helps to know the fundamentals when you're working on a game engine, to understand like how the engine probably works because you understand the way that computers work, that makes it easier for you to understand, comprehend, and use an engine, but it doesn't replace the need for one. I'm spending a whole lot of time on developing this tool for a portfolio piece, but all the time that I'm spending on its technology is not time I'm spending on a game, I guess. So what I'm doing here is not the same thing at all as like Notch making Minecraft, right? Because like Notch, when he made Minecraft, he wasn't making an engine; he was making a game, and that's the difference. So just use whatever gets you going in the morning. I follow a team of 3 game devs, and seeing the results they're getting out of Unity is really discouraging. Yeah, I don't know. For making a 2D platformer with less mechanics than Mario Bros. Yeah, I mean, like everybody has the my first game, right? They do a thing just to do a thing, and then it's better than not having done a thing, but it's not, great yet. That's not really, that's not the basis by which you should gauge somebody. You should gauge somebody by their best work, not their first work. But yeah, it's like one of the, I've heard this discussion recently about how a lot of folks seem to think that Unity doesn't make good games for some reason, and it's like it's nonsense. There's all kinds of amazing, beautiful games made with Unity. Like Hollow Knight was made with Unity, and Ori and the Blind Forest and Will o' the Wisps was made with Unity. Like really, gorgeous, like blockbuster quality stuff. But I think a lot of folks get this impression that if it's made with Unity, it's a solo dev that's not good at what they do, and it makes a bad game. But really, that probably comes from the weirdest portion of their licensing model, which is that if you go to license Unity, unless you get the Unity Pro, which you pay extra money for, you're required to put the Made with Unity thing on it. Like I've actually got a game right now, Cosmic Express, that I've been playing, and I'll bring it up real quick. It does this thing, Made with Unity at the front, because they didn't buy Pro. And this is a great game, by the way, Cosmic Express. But it's like, because that's a requirement for everybody who does the free version of Unity, where you don't pay until you've reached a certain benchmark of sales. All of the games that don't make money, all the ones that suck, in other words, all have that banner at the front, Made with Unity. And so what Unity has done is they've accidentally associated their brand with the games that don't do well. But it's nonsense. Unity can do very good things. And so there's some devs that obviously that don't do well and never will do well, but I wouldn't say that it's because they're using Unity. There's all kinds of amazing things being made in Unity all the time. Okay, so the low texture implementation. Yeah, so I think the implementation is working. I just need to get the value to be a string view, because it takes a string view for the path. So I guess I'll just do that now. I'll do that .str and then path node .val .len and put that in curly braces. And that should construct. Yeah. Okay, so I think that's all of these squiggles out of the way now. Cool. So with low texture implementation, then this is going to, it's not going to be a static function. It's going to be declared in the, not textures.h, but the internals version of textures.h. Like this. So this whole strategy of having an internal version of the header and a full version of the header, the internal version of the header is there so that the editor layer can see this stuff and game projects can't. So wrapping this all up in this function makes it so that I can call it directly in the engine layer, wherever that was, here in the content browser. So instead of calling load texture, we will call, I got lost again. Content.cpp, please. Here. So instead of calling load texture, I will call load texture implementation. Now these are not visible because I don't think I've been including the internal version of this header, so let's do that now. What now? Oh, this guy here. EP internal. So now we have the internal version of the header. These should resolve. Right? Won't they? Oh, except for I need to plug in the instance value now. because that's no longer an optional member. Cool. And that should be that. That should be working fine. Let me confirm that all the other references are A-OK as well. Okay, we've got one more in the sprite section. Other question. I follow quite a number of game dev on Unity, but they all end up to a point where they have to code something in C#, and they seem like they lack knowledge of C#. Like school taught them how to script, how to use the GUI, but at the second they need list, dictionary, the key value instance, they get lost. Is it because some schools should teach them more software architecture, or is the problem with Unity? Yeah, I would say it's the schools for sure. There are a whole bunch of quote unquote higher education places that they're like, come here, we'll teach you how to game dev. But if it's not DigiBen, then in general you're not learning how to do programming. You're learning how to use Unity. It's basically just like they are making money off of like reiterating what the Unity tutorial series does. Like Unity has online classes that teach you how to use Unity and teach you how to use C# to a good extent, but they don't. There's a lot of folks out there that like go to school to learn game dev, and then they just don't learn programming, and it's totally like I'm not going to blame the folks who went in and didn't learn programming, because programming is a part of what they thought they were learning. They didn't necessarily think that they had to learn how to program, but if they wanted to go into game dev, that means that they had to learn programming, and somebody out there sold them a degree that didn't include it. So yeah, I'd say it's totally it's less about the fact that people aren't interested. It's that yet learning something is hard, especially in programming and computer science, and like it really helps to have a good teacher. And if you don't have that, if you don't have somebody with knowledge teaching you, it takes a lot of self-discipline to be able to learn how to do something very well. And it's a much smaller pool of capable people are determined enough to self-teach themselves how to do programming correctly than the people who would prefer to get taught by a teacher. But yeah, that's there's a whole scam market out there on this topic. Yeah, so this is the R2D sprites. R2D sprites is where we were doing the sprite component loading. And this is where we do the sprite inspector. So if we add a file reference to the field by dragging and dropping or typing, then we would load up a new texture using this handle, or using the path. So now we can literally just delete this. So the load texture is now simplified to, you have a path to a texture file, and then this is the number of instances to load. So out text path, yeah, that's still a good name for it. This is the path that's outputted from the text field inside of the inspector. So that's fine. We do need to change the payloads that we accept, though. So presently it's kind of a hacky solution anyway. This is not even committed, the section, but it was accepting files of PNG type. We're now going to change this to be EBTeX, which is going to be the extension we use for texture files. Yeah, and then if you type in the file directly, it will work as well. Cool. All right, that's looking good. So we've got the code in a place where it should compile. So F7 and build it and confirm. We'll need to do some changes to the assets though, so that way we can still load the stuff we care about. Yeah, so build files have been written. How's the compiling going? I see the thing spinning on the corner, but okay, there we go. Non-void function does not return a value. Oh, what did I screw up? Oh, I need to return, yeah. So I overlooked a few things, so I need to return the value of the implementation value there, and I'll need to do the same thing probably for these. Return exists. Okay. Everything else will probably compile though. $71, yeah, it's the same that we just corrected. Whoopsie. Interesting that that's a warning and not an error. The fact that we don't return I mean, the return value is supposed to be a string, and we don't return anything. I wonder why that is. Call to virtual path to native is ambiguous. Okay, so there's another one. Let's take a look at that. All right, so there's a number of places where we have virtual path to native. We pass in a string. Okay, hang on. Really? Okay, that's annoying. So by adding the overload for std string view, using a const character literal will be ambiguous because you can use a const character literal as a string or a string view. You can construct either with just a string literal. So that means we actually also have to do a const char version of this. Okay, that's great. We can do this. So instead of doing const std string view up here, I'll take and copy it down below. This is where overloads get a little bit tedious, and we'll have to do something where we return the correct. We'll use a different implementation of this in a minute. But instead of doing this, we're going to do const char star string. Path, and then size t length. And when you do string literal, both of these are provided, I believe. I'm a little vague on how that works, but presumably you pass in a string literal into this and it automatically populates them. I'm not clear why. And then we'll have a version as well. We have to have a version of this which is a const char pointer without the length, and then this will return virtual path to native, passing in the path, and then the strlen of the path. Yeah. And yeah. Okay. And then this we do path dot data, path dot size. Okay. So these are looking okay, I think. What's this? Does not return a value. Oh, that's the warning from our last compilation failure. Okay. Const char path length. Okay. So this implementation now uses C-style strings. So in this case, we don't have access to rfind like that. That is, we don't have a class to have a member function rfind on. However, I think there is a regular rfind. Like we can invoke a static rfind. Yeah, size t rfind const char s. Hang on a moment. Are these static? These are member functions. You know what I should probably do instead? I think I've got a better idea. I will do this. I will have the const car version and the car version down below, and we will put the implementation inside of the string view version, so that the logic all works the same. We have access to rfind and so on and so forth. And then when we get the string literals, we construct a string view with it. Oh, but we have to do it like this. Do that. And then path is the pointer, and then length is the length. Okay. Let's review this. So this is the same function as last time. You do the C string literal, get the path and the length. We use that to construct the string view and pass it through. We'll want to do the same thing here, actually. So on this one, we construct the string view from the path, and then the length is gotten by Sterling. And then this one where we get the std string version of the path, we use path.data and then path.size. Okay. Hopefully that resolves everything. F7 to build. I got some more problems. What are those? Okay, there's still an ambiguous call. Really? This is still ambiguous? How did I do it on the hash names? I did it exactly the same way on the hash name function. Const car pointer, and then size t length. Const car pointer string name. And then string view reference. Actually, I just added string view reference, didn't I? Before it was just the string reference. But that shouldn't matter. It shouldn't matter at all. Okay, so what it's trying to disambiguate is the difference between the string view version and the string version. So actually, I will encounter this problem on the hash name version as well. So in hash names, I implemented a change here, and I'll undo it real quick. I implemented a change where we had the ability to pass in a string view. That seems to be causing a problem. So instead of doing a string view version, I will do just the C literal style, and then you pass in the pointer and the length, and then not have to construct a string view, which makes sense, I guess. But it'll also disambiguate those calls. So virtual path to native. Okay, I guess we'll have to do. We'll have to rewrite this a little bit. So instead of doing the implementation with the string view version, we will do it with the string literal version. This is the lowest level, the pointer and the length. And then we will have the car pointer, the null terminated string here, and we'll have the std string reference here. And we won't construct string view anymore. We will just use the C string overload. All right, so I'll have to do this a little bit differently. Without rfind, I would really like to just have a substitute for rfind, but we may have to do some loops here. Yeah, these guys literally just wrote their own functions for it, which is fine, but I don't want to do loops for this. Okay, so we've got these first and last appearances of the character. Finds the first appearance of the character in the byte string pointed to by string. And then we got the first occurrence of a substring. Okay, so this is the function I want. I love the parameters here, haystack and needle. That's very clear. So yeah, we pass in the pointer to the thing we want to search, and we pass in the thing that we were looking for the first instance of. Cool. So this is defined in CString. I believe I have that in my CMake tools or CMake lists. In my precompile here. Oh, I guess I don't. So this is the precompile headers section of my CMake list. So these are things that appear inside of the CPP files without me having to include them everywhere, and it also precompiles them, so it's faster to include them. I don't have CString in here, so I should do that now. This is alphabetical, so I'll do right underneath the C signal, like that. Save. That'll be available now automatically inside of my CPP files. And instead of doing rfind 0 for this, rfind is a reverse find. It means that you start at 1 and you search backwards. I said start at the 0th character, and then if it's not there, move backwards, which is a little bit of a trick to say only check if the first couple of characters is the string. And it compiles pretty efficiently as well. But instead of doing that, we're going to be using this. So we're going to say return value is a pointer to the first character found, or a null pointer if no such character is found. So we'll say if we find it, so that's going to be std stir. The haystack comes first, so we pass in path, and there's the needle, is the C /. If it exists, so it's a null pointer if it doesn't exist, otherwise it exists, then we will have oh, hang on a minute. Okay, so what I need to do here is I need to check if the pointer, not just that it's not null, but also that it equals the path pointer. The logic here is that if C/ is the first 2 characters of path, then this will return the same actually, this is a really stupid way to do this. Why am I doing it this way? I have a buffer. I can just do path 0 equals C and path 1 equals slash. Now this requires that the length is at least 2. So we'll say if length is greater than 2 and path 0 and whatever. And this evaluates first, so these we don't dereference 0 or 1 if this is too short. But I suppose if the length is greater than 2 anyway, we can just early out for that. Say if length is less than 3, because the longest of these is going to be 3. If length is less than 3, then we will return std string path. We'll early out. Okay. And then from here on, we know that we can access indexes 0, 1, and 2 fine. So we don't have to do the searching path stuff. We can just do this. And then instead of doing path.subster, what we would do is we would pass in, for the concatenation, we would pass in path plus 2. And then the second parameter for the length, we would pass in length. Length minus 2. So this will give us, construct a substring from this C string buffer. Okay, good. Good. And then we can do the same thing for these guys. I will copy and replace these. And then this will be similar, except for it'll be plus and minus 3. Good. All right. And then we can do the whole path 0, path 1 thing. Okay. CDS. Okay. And then with these, it's very similar, except for it's 3 of them. Okay, so this one we have EC/, and this one we have ED/ for editor data. Okay, that took a lot of typing, but I think that we finally got an implementation that allows us to do this in every context that we needed to. I'm a little annoyed at this because it looks like I'm going to have to do similar logic for the rest of these. But what are you going to do? So for like everything inside the file system now, probably I'll have to do overloads like this. But yeah, that's looking fine. Save it. And then hashnames.h. I needed hashnames.h to work with string views, instead of doing that, I will compile. When I get to the point that it breaks, I will use the link inside of the output to bring me to the spot where it's using the hash name function incorrectly. And I will, instead of using string view, I will use the C-string version of the hash name API. Okay, there's something. It's actually not what I was expecting to see. Warning, memcopy will always overflow destination buffer S. Interesting. That's not in my source, that's in the C4 library, so probably there's an issue with some implementation. Alright, here's where all the hash names broke. Textures.cpp. So on these, we can't simply pass in path because that's a string view and we don't have an overload for that. So what we need to do is we need to do dot dot data and then path dot length. A little awkward, but what are you gonna do? So everywhere that this is broken, I will paste in the fix. Control F. Okay. Replace. Okay, and then these ones are fine. F7. Okay, linker error. Undefined symbol, hash name, application.cpp. Did I script somewhere else as well? So there's an std string const reference passing into hash name. This issue comes from the static version, not the dynamic version. Okay, so I made some changes that work fine in the. Let me change my build target. They work fine in the static version, but not the dynamic version. I found a small 1 hour and a half classes on LinkedIn about concurrent programming. $60. I think we'll try it. Yeah, the I wonder if it's the one that I took, the parallelism course. I forget what it was called, but that's where I studied parallelism and how to do multi-threading. So yeah, if it's the one I'm thinking of, then it's a good one. So yeah, let me look at those warnings again. Okay, so in application.cpp, here we are referencing hashname, class, std basic string. So an std string version of hashname is being referenced here. Okay, that's all well and good. Right? Isn't it? Oh, except for I made them constant. Yeah, let me undo this. Okay. I think I've spotted the problem. Alright, hopefully that's it. Another case of I changed it in the header and the CPP file, and then I undid it, but only in the header. There we go. Now it's built in compiled. So okay, everything is built at least. Before I forget about it, I do actually want this function to be for const string references. So let me implement that real quick. Hashname const std string by reference. And where's the full version? Here. Oops. Const std string reference, so we're not doing a pass by value. And what are you complaining about? Okay. F7 to rebuild. Confirm that's all working. Is the $60 price for LinkedIn learning in general, or just that specific course? Back when I took the course, my company was paying for it, so they my LinkedIn account had access to every course on LinkedIn Learning. Okay, we got a problem. What's this? File.cpp. Okay. What's the problem? Undefined symbol, basic string is the return value. Virtual path to native. Taking in a std string view. Oh, okay. Yeah, we don't have string view anymore. So this one is going to be path.data and then path.length. And this will use the overload that accepts the C string buffer API. Okay. Is that the only one? No, there's also this one. Is path... That's a string view as well. So yeah, these will have to be dot data path dot length. And replace that in there as well, and in there as well. Okay. Okay, there's still more. I'll use the problems list for the first time in a while. No matching call to virtual path to native. I don't get it. So the oh wait, virtual path to native. No, that's right. Conscar pointer path. STD string reference path. It totally should work. I am not following. Okay. Now matching function for call to virtual path to native. We pass in path.data, path.length. That gives us a const car pointer and a size t. And we have const car pointer and size t. Did I screw up the header? Is that what this is about? File.h. I have a feeling I screwed up the header. Virtual path to native. I did, I screwed up the header. Okay. Dang it. It's always something. So in virtual path to native, we use this signature. Okay. And I need to add the param for length. Okay. Just to review the implementations, we've got 3 versions. There's the std string, constant std string reference version, which is what we've always had, virtual path to native. And then there's the card pointer version, and then there's the card pointer with the length. Okay. Like that. Okay. Gosh, it's annoying. Alright. F7 time. Let's see if it finishes compiling now. Of course there's a problem. What's that? No matching function call to virtual path to native, so textures.cpp this time. Okay, so there's more instances where I'm passing in a string view. Okay, so I'll need to look for this string inside of the bounds of this function. Okay, so there's a little bit of a trick. I'm going to collapse the whole function, shift select around it, and then turn on the find it selection. Oh, this is the only case of it. Okay, never mind. I thought I was going to find a number of cases where I used path incorrectly. All right. So this will be path dot data, path dot length, like that. Cool. So what else is giving us grief? Console.h. No matching. Can huh. That's a bit strange. I have a sneaking suspicion that all of those other warnings and errors were from the same thing, but they were alerting me to like implementation problems associated with it. So F7 time, hopefully this will just work. Oh, we're getting close. 39 out of 42. I shouldn't have said anything. All right. Couple of linker errors, it looks like. Referenced by content.cpp. What is it failing to link? Undefined symbol. Where did I see that? Undefined symbol. EP graphics, low texture implementation. Class SSD basic string view. So a version of low texture implementation. Oh, I didn't export the symbol. Okay. No problem. This would be in, graphics.h inside of the EP internal header. Wait, what? No, inside of the textures header. Here. Yeah, so basically I just forgot to do this thing. And that's totally fine. So we'll do include enterprise core shared library exports, and I'll move that to the top. Cool. And that'll expose it to the editor through the DLL interface. Okay, finally, after all that, everything's compiling and so on. So even though it's compiled, I'm not going to run it quite yet because I need to actually set up the content to work correctly. So the scene file, if we go to the basic.av scene, has extra values in it now. These things will be ignored. However, the paths still point to PNG files, and I need them to point to something else. So what I'll do is instead of doing .png, I'm actually going to Control F and replace all of the PNG extensions with .eptex, EP texture extensions. And now everything is pointing to a file in the same place, but it's a EP texture instead. And that's important because now we are going to surround the textures we're using with texture assets that'll actually be consumed by the engine. So yeah, I'll need to go to software, enterprise, test game, content. All right, this is the content folder for the test game project we're working on. This is the textures folder. We get the file folder. Those don't actually have any place here. These three textures are the ones that are loaded by file. So I need to have in this folder references to these files. So I guess I could do this inside of here. So it will be C textures text1. Right, text1.png. Test game content textures, yeah. except for that's a lowercase textures. C textures text 1. Oh, hang on. Did I do lowercase on the paths in here? I did. Okay. Good. And then I'll save this as in the same folder. I will call this text1.eptext. And then I'll repeat for the others. So Control-Shift-X to save as text2, and in it we'll change the texture file to text2, and then we will do Control-Shift-S again, and this will be text3, and then change the name to text3 as well. Okay, so now we've got in the basic scene file, it'll reference the eptext file, calling load texture on it, and it will from there parse out the details to make the texture work. All right, moment of truth time. Cool, we're back up. We didn't break the file icons. That's good. Let's open up a scene, basic scene. Aha! All right, cool. So now we have a scene that loaded. Let me go check out the debug console. No errors or warnings in the debug console. So it loaded all the same textures as before, but the main difference is that the textures are not being loaded directly. Instead of loading the PNGs, these things, it's loading the .eptext files, which is referencing them. So one way that we could demonstrate this would be to change the which one's text3? Looking for a link. So link is text2. So inside of text2.eptext, I'm going to change its minification and magnification from nearest to linear. And so if I was to go to reload this scene, oops, back, scenes, reload the scene. Oh, I thought something would happen, but, oh, we got an error is what happened. What do we got? There's an assertion failure that just happened inside of the new YAML parser, so there's an educational moment. So we are doing find child. And we failed an assertion is map. So let's go up the call stack a little bit, see what source code I did that actually broke this. Here. Okay, so what the line that broke this was path node equals tree path. So and which file is this? Path is C textures text1.png. Okay. Wait. Text1.png. It's trying to load a PNG file. Oh, because I opened up the wrong scene file. Okay, that's my fault. Well, it's kind of my fault. It's my fault in the fact that I tried to open up the wrong file, but I still need to have handling for this situation. So path node fails because tree is not a map. So I need to do the map check above trying and failing to get the path node. Okay. That makes sense. Let's try this again. Okay, link is still looking crisp. Oh, you know what? I have an anti-aliasing shader in. Okay, so actually, that's not gonna work. I have to actually make a change to the shader here. Real quick. I have this whole thing, this whole algorithm set up to take the texture and automatically do anti-aliased lines between the pixels, and that takes the linear interpolation and then actually works with it. So if I was to load the scene now, now that I've disabled that, wait. Scenes, basic scene. Link should be worse now. Okay, so Link is worse now. You can see the anti-aliasing is gone, but he's not blurry, so something's still not working. If I go to text2.eptext, that changes its min and mag filter to linear, so that should be fine, but it's not working. And I'm not seeing anything in the debug console saying there's a problem, so what gives? There must be a problem with the way I've done the min and map convert. It's defaulting to nearest and not changing from the default. My best hunch is that maybe the problem arises from no, that wouldn't be right. So I'll set a breakpoint and reload it. So we'll go File, Close Scene, open the scene again. Okay, so min filter node is a key value pair, it says. We'll step into this line of logic, out of that, and then into this. Out of that, and come on. I want to get into string to text filter. Okay, here it is. So the data that we got out of the node is nearest. Oh, this is for not the text2, but the text1. So we'll hit continue. And which path are we on now? Text2.ebtext. Okay, so this is the one. So we'll step into string to text filter. I don't get it. Okay. The string that we got out of it does say linear. It says on the top left. Okay, and then we have a return of the linear of the linear type. So min filter is set correctly. Yeah, this looks correct. Min filter is linear. Mag filter is nearest. Okay, so something's wrong with mag filter. All right, so something is up with the data we're getting back from magfilter for this file. Okay, so here's a call on loading texture 2. By the way, this load texture call, I keep stepping forward and it keeps hitting this breakpoint. That's because we're loading up 12 sprites, and so it actually calls this for each one. Oh, it's calling it for each one. That's not a problem right now, but it will be. I need the reference counting to avoid going through the logic on a per texture asset file basis, not on a per PNG basis. So we'll have to reverse the order of things here. I'll do that offline. I'll do that later. But for now, EP text 2, mag filter, node. Yeah, okay. Stepping in. Gonna do the trick I did before where I hit continue. Okay, so here we are. So the string that we got in was linear. And so it does return linear. So mag filter. But magfilter still has not been assigned. It's still equal to nearest. What am I missing here? I don't understand what's happening here, even a little bit. So I'm cycling back around to loading text 3. Let me do a conditional breakpoint on this guy. And then we will did shit just crash? Hang on. Open up a scene, basic 2D scene. Alright. And turn off that breakpoint and hit continue. Alright. So okay. For some reason, the condition is not hitting correctly. It's hitting on the line regardless of whether the condition's met, but whatever. Let's step into string to text filter. I'll set a breakpoint and hit continue. Okay, so the string that came in is linear. Okay, and it's now on the line return texture filter linear. So it should be returning linear, right? Okay, and it did return linear. It says so right here. String to text filter returned linear. Good. Mag filter is still set to nearest. Oh, it did get set to linear. Wait, it says mag filter. There's more than one mag filter. Did I redefine mag filter on accident? Hang on a minute. I'm seeing more than one mag filter listed here. So here's the node. Here's the declaration. It's defaulted to nearest. Oh my gosh. I don't know how I didn't see that. All right, so this is annoying. I accidentally was redeclaring these because I copied and pasted the code from the declaration, and I forgot to delete. Okay, that makes a lot of sense. We're done now. Clear these breakpoints. F7. And we should start to see a blurry link to confirm that the asset's working. F5. All right, scenes, basic 2D scene, and there we go. Okay, this is proof of concept. So, whereas you see Madeline over here is all pixelated, just like the artist intended, Link over here is very blurry, and that's because when we loaded him, in his EP text file, we set the minification and magnification filter. Well, the only one that matters here is the magnification filter, but we set the magnification filter to linear. So when he's too big to fit one pixel per pixel, the sampler in OpenGL is interpolating between each pixel color, which makes it blurry. And so on this file, we can change it back to nearest, hit save, and then reload the scene. And he's not blurry anymore because we reloaded the texture and the asset file is, yeah. Okay, cool. So that's pretty good. I think I'm gonna call it a stream for today. We got a rudimentary texture asset system going. It's very bare bones right now. And we also tried out the Rapid YAML library instead of YAML CBP. Kind of got some learning curve problems and some issues with interoperating between my code and its code because it uses all these C4 core types. So I have to do awkward conversions between my string types and its string types. But it does seem to be pretty usable. To be honest, though, I'm not sure that I want to replace YAML CPP with it. I know that it's faster. But in the case of extensibility, where, for example, I need game specific systems to be able to extend what's written into the scene files. So if you have your own special component types, you can encode that into your scene files. I need it to be simple enough to ask a developer to say, hey, here's a library we use. Go to town and write all the YAML out that you want. What I probably need to do I probably need to wrap the Rapid YAML library. It's a dang good library for what it does. Because what it does is it's high performance. It's no exceptions, no silly extra object-oriented C++ business. But it's not super friendly if you're not already using the C4 core utilities. So I'll have to think about this. Maybe I can wrap the Rapid YAML library, and so that way there's a enterprise YAML library wrapper that you can use instead, where it's all nice and friendly and everything plays nice with each other. Or maybe I can find a way to extend the Rapid YAML so that way it will automatically handle conversion between C4 types and our types. I don't know. I'll have to think about this. But for now, the broad strokes is that we have texture assets now. And getting them to do more things is just a matter of expanding the scope of the YAML parser. And we can already do this, where we change the texture details in the file, and it updates inside of the engine. But yeah, thanks for joining me. I'm not sure if I'll be back tomorrow. It depends on how far I get on this Rapid YAML question tonight. But if I'm not back tomorrow, I'll probably be back the day after. Take it easy. We'll see you later.